Hi, everyone coming in. We have Colby, Mario, welcome.
Oh, yes.
Sina, welcome. We have Mara from the Amii team. Welcome, Mara.
Hey, Svon.
How is everyone?
Good.
So as we slowly start checking people into the meetup, feel free to chime in and let us know where you're coming from. So I can start. My name is Vaughn, and I'm in Edmonton, Alberta. Sina from Edmonton, welcome. Bernard from Edmonton, welcome. Mara from Beaumont. Mario, welcome, another Edmontonian. We have some Calgarians in the room as well. Feel free to represent. Brent, wonderful. Some more Calgary people coming in. Welcome. We have Ali from Drummondville. Welcome, Ali. Excellent. So I think the team here is pretty much close to letting most of the folks from the waiting room in. So I am happy to get the ball rolling on this March edition of the AI Meetup. Welcome, welcome everyone. My name is Vladimir Rack. I am the Marketing and Communications Associate here at Amii. We're seeing some folks coming in from Calgary, from Edmonton, from Beaumont, etc. So we have lots of folks from Alberta tuning in. But if there's anybody who's outside of Alberta, feel free to wave and say hello. But for those of us who are joining us again, welcome back. And for those of us who are joining us for the first time, Amii is the Alberta Machine Intelligence Institute. Amii is one of 3 centers of excellence as part of the Pan-Canadian AI strategy. And there's a history there reaching back to decades of world-leading AI research and training that has put us in a position as one of the global leaders in AI and ML. So whether you're involved in a business or you're a student, or you're just looking to get more involved in the AI community, Amii has a whole host of programs and resources to support you, and we would love to connect. So please reach out to us at amii.ca, or you can send us an email at hello@amii.ca to learn more. But a few housekeeping notes before we get started. This meetup is going to be recorded, so we will have this meetup on our YouTube page as soon as possible, so everyone can view it or revisit it at their leisure. However, you can expect this live meetup to be about 1.5 hours max. So we are excited to see all of your faces and would encourage you to keep your camera on throughout the meetup so that the presenters can see you and gauge your reactions. And finally, as we continue to improve these virtual events with each iteration, you can expect an email after this meetup with an incredibly short survey to let us know how we did and what we could do better next time. So we wish to hear your feedback. It helps us out a lot. But housekeeping aside, we have 2 great presentations for you this evening. There will be a quick Q&A session after each presentation for any questions that you may have for our presenters, at which point you will be able to either unmute yourself and ask your question, or alternatively, you can send your questions into the chat at that time. But we can jump right into the content if everybody's okay with that. So allow me to introduce our first presenters, Reg Ouellette, who is VP of Engineering, and Alex Trad, who is Director of Business Development from Chata Technologies Incorporated. And you can visit their website at chata.ai. Hello, Reg and Alex. Thanks for joining us today.
Thanks, Vaughn.
Thanks, Vaughn.
And feel free to kick us off the screen share here.
All right, let me get this going here.
Do you want me to go ahead and share, Reg, and start the demo, or do you want to go ahead?
No, I'm going to go first.
Sounds good.
So hopefully everyone's seeing that. I have to do the perfunctory. Can you see my screen? So today I just want to talk a little bit about sort of Chata's experience with the cold start problem. I know anyone looking to start a company or make some money in the machine learning world is going to certainly run into this type of thing. Let's jump into it. So, before we go too technical, let's just give the high level of, what is the cold start problem? And basically what it is anyone who's looking to train a high quality model is going to need some really good labeled data to train a really good model. So so the question is okay, well, how do you get there, and where does this data come from? So rather than trying to just be high level, I decided to describe sort of one instance would be like if you were going to be building a model to predict sort of impairments in healthcare impairments, say a heart. Like data certainly exists out there to do that type of thing. We've got thousands of MRIs and imaging happening in hospitals all around the world. So it's exactly the type of data you need: high quality image, and then obviously labeled by the highest experts in the world, describing exactly what's going on. Now, a big problem there, what we're going to run into, is the fact that we may not be able to actually get our hands on that data. HIPAA laws are quite aggressive, and if you manage to get your hands on that data, you can certainly create an excellent model, which our CEO Kelly could talk about because his past company was actually in that space. If you can't get your hands on that type of data, another option is to potentially build some systems. Now, I was reading earlier about CAPTCHA, and I mean, I'm sure everyone on the call has run into CAPTCHA. They want to know that you're not a robot. And it was funny because they were talking about how it was a battle between the optical recognition people automatically filling these in so that their bots could work versus changes on the CAPTCHA side. And in 2011, they actually repurposed CAPTCHA and called it reCAPTCHA to actually start to crowdsource optical and character recognition. And I'm certain that they ended up making a pile of money doing that type of thing. Now, these are a couple of options. Go find your data source, potentially buy it. Or build systems to do that type of thing where you're going to generate your own training data. And the last option, and for those of you who know, that's Dinesh from Silicon Valley. And if you know it, this is probably one of the funniest things for labeling data that I could run across was in Silicon Valley, the not a hot dog episode is absolutely hilarious. So here we are, we get our labeled data, we're ready to train, we're good, we're done, right? Well, not necessarily. Depending on your business model, you may actually have to have continuous startup. If your system is such that you're building a model for, if you build one model for many users, so, sort of taking on the Sauron approach of one model to rule them all, you're probably okay. You'll have one data set or corpus, and you'll be good to go. But if you're looking to have many models for many users, kind of a many relationship, then you're going to have a way of constantly, solving that problem. We've built our own speech to text internally at Chata, and it's still sort of sitting in our background. We haven't exposed it yet, but we've used one of the pre-trained models, and an interesting thing comes out of it is that whenever we're using our speech to text to sort of ask a question like, "Hey, total sales by customer," the speech to text actually recognizes it as sales on a sailboat. So that pre-trained model is actually not quite working for us. So, you may still need accurate corpus to augment even pre-trained models. So that sounds like, oh, that really sounds like a bad problem. And, hopefully Batman isn't slapping me. But it's not all bad. Basically, because of this, the difficulty of this problem and the ability to get your hands on good data sets, it breeds opportunity, right? So we'll have lots of companies that are literally just services-based companies that are looking to go in, build a very specific data set, build a very specific model to solve a specific purpose. It's a great niche area, can build a very viable company doing that. But if you're looking to have a product or a platform, then you're definitely going to have to think about how to solve this problem on an ongoing basis, potentially. So to talk about how we're solving cold start, I figured we'd give you a little bit of history of Chata, where we came from. 4 years ago, I started with Chata. Our focus was, after the initial sort of startup, was we were going to go into the financial space. We were going to build models that connect into cloud software, anything that had an API that we could leverage to get data. We were able to build a model for that specific purpose. So if you think about the problem space there, we were building the database based on the API structure, kind of reverse engineering. It was relatively simple structures. Most APIs, in this cloud space, 30, 40, 50, endpoints. So reverse engineering it, we ended up with database structures of 50, 60 tables. And then we were in a very specific business space of, financial sort of accounting domain. So it wasn't too bad that way. Our Chata service, it's a SaaS. It's basically allowing people to, when I say people, SMBs, to query their financial data through natural language. So we worked on that for the first couple of years, and we got to a point where we're in a number of marketplaces. It was business to consumer, and we sort of fell into this fact that we were really in a good space to go to business. So rather trying to build a platform, we decided, hey, like, what can we do with other ISVs that we would build models sitting on top of their database? So what that meant was we totally lost scope of control. The databases were not under our control. We couldn't change them. In lots of cases, we would run into quite large databases. One of the wealth management systems we integrated with was 800 tables, 2,000 columns, so quite large. And then also, we're not sort of stuck in any one business space. We talked wealth management, we were looking at ticketing, we were looking at inventory. All of these have vastly different language characteristics, right? Like people in ticketing don't ask the same questions as someone's in inventory. There's some overlap, but there's definitely their own language. So those were the challenges we decided to take on. And this is where we ran into our iterative cold start problem. Each new company that we're looking to integrate with, it was a start over. We had a new database to deal with. We had to figure out, what were the important queries that people might want to know, and how are we going to generate all the necessary data to train a model that's going to actually work for the people using this software. Like if you think of a bottom-up approach of permuting all of the tables and columns in the database, like we put billions or trillions, but I was just chatting with one of my data scientists, and he's got a very strong math background, obviously. And I asked him, like, what would sort of the algorithm be to calculate how many variations? And he said, we're probably looking at 2 to the number of columns in a database. So, I did a quick math on 100 columns, and it was like 1 times 10 to the 30 permutations of every possible SQL query. It's a total estimate, but you can see that the volume is just so vast that we quickly realized that we needed a very strong approach into building corpus for our model. So basically what we had to do is come up with some very clever approaches, build some proprietary technology to help us build this. We also don't necessarily always use a bottom-up approach where we're coming from the database up to the language. At some points, we also want to come down from language down to the database. And that way it allows us to sort of minimize the amount of data that we create. We're able to create the important use cases that solve problems for businesses rather than just any possible piece of SQL that you'd ever want to run. I know, having years of experience with databases, I've never run a query with 20 group bys. So no point in generating that type of query. So because we're crazy, we decided to take this a step further where, Chata was looking to build integrations, into single ISVs. And then we said, hey, well, all this capability that we're building around corpus generation allows us to potentially go into a do-it-yourself mode, where now we provide a platform where people can come in and actually generate their own corpus. Although it's completely abstracted from them, they're really just gonna go in, connect a database, and then get a model out on the back end. So it's kind of funny. The whole do-it-yourself thing is it's immensely complex, but it's immensely powerful for us because it would allow us to scale, almost, there's no scaling factor. It's not about how many people work at Chata that we can take on integrations. It's just, we just need to have a platform to allow people to do that. So our alpha, we're working on it. It'll be closed alpha. If anyone's interested in maybe trying it out, I have my contact information coming up here after. I gave myself a timer. I see I'm at 10 minutes now. And I know I started my timer a little late, so I don't want to make Zvon's hair look like my hair. So I better just move on a little bit. Here's my contact information. I'm sure this will be available, Zvon, for everyone. I will actually pass it on to Alex, who is going to be doing a quick demo of our AutoQL platform.
Thanks, Reg. Appreciate it. I actually have a timer about to go right now too, so we're one and the same. Hi, everyone. My name is Alex Trad. I'm the Director of Business Development, and I'll be presenting a demo of our solution today. Just want to make sure that everybody can see my screen. I can't see you, so Erica, if you can give me a yes, that'd be great.
Yeah, you're good.
Awesome. So I'll be demonstrating the power of our solution, how users can leverage natural language to be able to access and analyze data in their database simply by asking for it. So I'm going to be demonstrating 2 of our open source widgets. One is called Data Messenger, which is like iMessage for a database. Go in and do ad hoc reporting to really be able to get the answers that you're looking for right away. And then we also have a dashboarding tool, which leverages the same technology. So let's just jump right into it, demonstrate Data Messenger. So we built this specific demo environment around a QuickBooks database. So it's going to be heavily financial. But like Reg mentioned, so we build custom language models based on the database we're working off of. And from there, users can come in and start querying for data that's most important to them. So here you can see this is where the user can come in and start querying against the database. We do give some topic suggestions around the database itself and the platform. We also have explore queries. So now users can come in. If the suggested topics aren't on the main page like you saw here, explore queries allows the user to come in and really explore, well, what kind of topics or what kind of questions can I ask around specific topics? So you could ask, well, I want to know, expenditures, right? What can I ask around expenditures? And from there, the user will get an idea as to what kinds of questions they can begin asking. Now, you're not limited to these, but it gives an idea of where to start. And then we also have notifications, which give the user the ability, and give the user the ability to set up a notification around whenever data is entered in. So every time a delivery for a PO that's over $15,000 is submitted, you can get a notification. So let's go ahead and start querying the database. So it really allows the user to use true natural language. So if I wanted to know, purchase orders by vendor this year, all I have to do is go ahead and type and launch that. So as I launch the query, the data is returned back to me in real time. I could begin analyzing this data. We give you different ways to visualize it. If I wanted to visualize it in a line chart or a pie graph, I could do that as well. I could also export this out to a PNG file, or if it was in a column chart, I could export it to a CSV. Now, when we try to drive home that we use true natural language, it's really important to demonstrate how we account for human variance. Because with natural language, you have to be able to account for different ways people ask something. So in finance, someone could ask a question like account receivable by customer. Pretty simple query, right? Something that accounting is going to want to know, what's outstanding. We see the data is returned back to us, that's great. But when it comes to humans, if you ask a human to do the same thing 10 times in a row, they're going to do it a little bit different. And our system accounts for human variance. So I could also ask questions such as, who owes me money? Right, which is, we're going after the same kind of data. It's just being asked in a different way. So you can see that the data returned back to me is the same data that I got back when I asked accounts receivable by customer. So the power of our technology is to empower non-technical business users to feel comfortable that they can go out and get the data that they want to make data-driven decisions in a more efficient manner. We also have our dashboarding tool here, which works off the same technology. You can see I've already set up some custom ones, and these are consistently updating as I log into the platform. To set one up, all I have to go to is into edit dashboards. You can see here that it's now in edit mode. This is where you launch the query, very similar to how we did it with Data Messenger, and then we could retitle that query. As I go to add the tile, it forms at the bottom there. I could do the same thing, who owes me money? Oh, fingers are typing quicker than I can speak, but let's see if I actually still might account for it. Yeah, so it does. So it does account for mistakes. Now I could retitle this. I can go account receivables. So every time I log in, I know what the data being returned is. I could also go into a split screen option, which allows me to visualize the data in two different ways. And then I could also export this out very similarly to like a PNG file. So the user can consistently set up these custom tiles around data that they need updates to or insight to often, whether you're a sales leader or a manager or a head of marketing or head of engineering. There's always going to be data that you're looking for that you need insight into right away, or either daily, weekly, or monthly. So by being able to set up these dashboards, it does one of two things. One, it allows you to have insight into that data, but two, it allows you to start exploring more, because when you launch a question like total expenditures by vendor, by vendor, there we go. So when you launch a query such as total expenditures by vendor last year, other questions start to come up, and that's when you can start leveraging Data Messenger to do that ad hoc reporting on the fly. So that's our solution in 5 minutes. Hopefully you enjoyed it, and we'll obviously be taking questions later on. So.
I am muted. Here we go. You can hear me now. Thanks for that, Alex and Reg. Let's take a moment to receive questions from the audience. Please feel free to unmute yourselves or ask any questions in the chat. Well, I'm happy to get the Q&A started. So, what languages do does your service currently support? And do you only support SQL?
No, so basically I use the acronym of MLMQL. So basically what we're building is the ability to build any language on the natural language side. So currently we're already integrated with a company from Mexico where we're building language in Spanish. And on the query language side, obviously SQL is still, you know, the lion's share of what we do, but we're actually integrating with Microsoft Dynamics, which uses an OData specification. So basically, we're able to generate OData to query the Dynamics. SAP actually also uses OData, so that would open up that domain as well.
Excellent, thank you for that. Any more questions? If not, I have one more, if that's okay.
Actually, Vaughn, if you want, I just maybe just as a
go for it.
Info thing for the folks. What Alex was showing you is not a platform, and you know I actually, in my rush to get through my 10 minutes, I forgot to say that we're actually an API. The widgets you were seeing are meant to be given to developers to inject into their software. It's not people logging in and seeing this. So much so that we actually have built an integration into Teams for in the enterprise space where they may not have a place to land widgets or may not want to use the API directly. So just wanted to be clear that it's all API based. We provide actually open sourced widgets. They can actually be, you can go in, extend them if you want, as long as you're using our API, we're happy for that, so.
Excellent. And so you offer your services to various industries, you know, automotive, healthcare, government, manufacturing, et cetera. I'm curious to hear, are there any industries that are really adopting your products and services faster than, say, other industries are?
Yeah, I could answer that, Reg. So the industries that are adopting it at a quicker rate, where we're noticing is financial services is a big industry that's adopting our technology, as well as energy. Being in Alberta, having that home base, a lot of energy and oil and gas firms have been adopting it, just because we've been able to demonstrate a lot of use cases for them to generate that data, but as well as healthcare. So I would say those three is financial services, energy, and healthcare.
Final chance for questions.
I have a quick question. So I was just curious, what are the algorithms or mechanisms that you are using to process the queries in the natural language domain? And how do you generalize that from your integration with different languages as Spanish, for instance?
So in terms of being able to, so we have to generate corpus that's language specific.
Okay.
Yeah, it's at this point, it's not a matter of one model and then just fire any English at it. If we're going to do an integration that needs to be bilingual or completely, I wouldn't say completely open, because I don't think we'll ever do that. But you know, if we would need to say support English and French and then maybe Spanish for, you know, in Canada, then we would have to build 3 models that would handle that. Actually,
right.
Let me restate, 3 corpus for sure.
Okay, thank you.
And we have 2 questions in the chat. I'm happy to read those out. One reads from Peter, would you mind sharing the limit of any asking questions? So what if the question of interest is a regression or a forecast based on the data instead of a bar graph?
Yeah, so basically what we say is, right now we don't do forecasting. You know, we're not trying to build forecasting models, but in the places where we've talked to people, that work is often already going on. So what we can do is build our model on top of any forecasting that's going on. In the QBO world, what we did is one of our data scientists actually generated a cash flow forecasting model, and then we built our natural language model to ride on top of it. So that capability is there. We haven't tried to generate directly where we're going to build forecasting. it sounds like a fun challenge. I wouldn't be surprised if we go there at some point, but that's a pretty difficult thing. The other problem is that you know, like regression, like linear regression, maybe, but to be honest, it would be actually, this is the way I explained it. I didn't need Chata for me to query a database. I know databases, and I know SQL, and it would just get in my way. For data scientists, this wouldn't necessarily be a good approach. They know how to build models. They're playing with all these different, algorithms that they'll want to test with. To try and do it through natural language is not really going to be, a good approach. And again, our customers are not necessarily data scientists. They're more the business users that just are having trouble getting their hands on data. I know in my past life, as much as BI teams try to be effective in getting reports out fast, it was weeks to get a report. And, we're talking to some people where it's like, hey, I need to make a $10 million decision, and I need to know now how many blue shoes we sold to people from 25 to 35. I don't need to know in 6 weeks, because then that's way too late. Yeah, so we're not trying to do that yet, maybe in the future.
Excellent, thanks for that. One more question in the chat. Can you talk a little more about the do-it-yourself customer data generation?
Yeah, very difficult problem. And I mean, what we were seeing, our goal for 2020 was to get it so we could build them all in a month. And that was a bold goal. Like at the beginning of 2020, to make that goal for the end of 2020 was like, holy, that's a hard problem. So now basically with the DIY, what we're saying is, oh, well, someone who doesn't know anything about what we do can now do it in half a day. So that was a very bold goal. The idea is that we would have guardrails up. Obviously, the person doing it is not meant to be the business user. It would be more of a DBA, a business analyst, someone who's knowledgeable around the data structure that would help construct and help us understand the relationship between a physical and the natural language layer. I can't go too deep into exactly what we're doing, mostly because we're still working on it, and the other side is because it's totally proprietary.
Totally understandable. Okay, well, two more questions from the chat. Would your API support a mix of two languages in a single query, like English and French?
I have to get back to you on that, around what the implementation would be. I'm not sure if it would be two models where we would potentially build a classifier up front to just route the call to the right model. The other option is potentially we could use browser capability to say, oh, I got my browser set to French or Spanish or English, and then route it that way. At this point, I would say we probably are going to want to know it on the way in. So I probably have to get back to you on exactly what that implementation would look like. My gut's telling me is that we would have a flag there on the API call to say it's Spanish or it's English. And hopefully the implementer of our widgets or the user of the API would just pull it from the browser and send it to us.
Awesome. And then one final question. Reg already discussed the complexity of the data. I am curious if the data is not homogeneous, i.e. outliers and exceptions.
Yeah, so just to be clear, we build the SQL and run it on the database. So we're not a platform, we're not bringing it over and we're not cleaning it. So the dirtier the data, well, we're gonna show you all the ugly data. It's basically gonna be an analyst who's been asked a question that's gonna generate SQL without a whole lot of cleaning. So a great really use case for us is to sit on top of a warehouse where someone has already, done the work of, wrangling the data and cleaning it and putting it in a spot where, a lot of really excellent business usage can be gleaned out of it, and then hopefully cleaned up so that things are tossed out.
Wonderful. Thank you everyone for your questions, and thank you Alex and Reg for the presentation. Please give a virtual round of applause to them. Thanks for that. Now, before we move on to the presentation from Salome, we would like to take a moment to invite you all, the audience, to give a shameless plug to share with the group anything around like what you're working on. If you have any exciting news to share on behalf of your organization or your research, or whether you're hiring or you're looking to be hired or you're looking for mentorship, this is a great chance to kind of raise that awareness of what you're up to and what you're looking for within the community. So if anybody would like to take a quick moment to share an opportunity or an ask, please do so now. But if nobody does, I would actually, I see Adam in the room here. I would like to actually just bring Adam, our newest team member at Amii, who is now the newly minted product owner of our startup stream. Adam, would you like to please introduce yourself?
Yeah, hey everybody. My name is Adam Danieleko. I'm the new product owner, like Vaughn said, for the startups program. So really excited to be joining the Amii team and kind of dig into what this role is and what all the opportunities that are available for us when it comes to startup work. There's lots of stuff going on. There's lots of opportunities. So right now, this is my first week. I started on Monday, so I'm really just diving in and making sure I fully understand what's going on at Amii and all the different teams, and seeing how my team, my new team, because it's a new team for Amii, how it's going to fit into kind of the puzzle that already exists in the organization. So really excited. I have a scientist, machine learning scientist, starting on Monday. So we'll be co-creating a lot of our programming and building it out and doing a lot of customer validation work and customer discovery work. So really excited to be kicking this off and joining the team here at Amii. Yeah, thanks, Vaughn, for having me here tonight.
Yeah, thanks for chiming in. We're very excited to have Adam coming on. So thanks for introducing yourself. I have one more plug if nobody else does. Maybe, no, that's all right. Because there are some mobile themes at this meetup tonight, I just want to give a quick shout out to the Edmonton mobile developers community. They are a group of programmers and designers that are interested in mobile development. They meet every fourth Wednesday of each month through Startup Edmonton. So if you are interested in exploring more content around mobile platforms, do check them out. I'll paste their meetup link into the chat. And yeah, okay. So awesome. Thanks everyone for that. Let's move on to our second presentation from Salome Perez. Salome is a PhD student studying at the University of Nebraska-Lincoln. So please join me in welcoming Salome. Thanks for joining us this evening.
Okay, hello everyone. I'm glad to welcome you to this research talk. I will bring a topic about cross-layer vulnerability detection in software applications. And so have you ever wondered, as we daily interact with more sophisticated and futuristic applications in our today lives related to mobile usage, or all the gadgets we have available day to day, how is the availability of those applications playing with your data? And if you are confident enough to say how these applications are handling some sort of data that might be risk to security for each person. So actually it turns out that these applications mainly are developed using Java or Android for the mobile market. And also the emerging IoT devices, their programs are, one part of the programs are done using a platform that's called Arduino. And all these applications at some point in their lives will rely or make calls to binary libraries. So if these binary libraries have a vulnerability, or they are exposing in some way some leakage of information or some memory damage by processing the code, that will make also all these applications vulnerable. So in fact, did you know that I placed Android case because in the mobile application market, more than 80% of the overall market, it's itself dominated by Android. And also there was a nice recent study that provided with this percentage. They pulled 54, the top 540 Android applications that are more popular. And they study and they provided the fact that around 85% of those are for sure make a call to a native binary library. And also the problem with relying on a binary library is that some of the vulnerabilities can be very risky if they are not attended or if they are not provided a solution or a bound. So actually it turns out that in an average, native binary the time that developers take to release patches for native library bugs are 3 times lower than the time that it takes to release a new version. So here, I wanted to show you this table. It's from their study. This study it's published in one of the top conferences in computer security, and it's called "Too Quiet in the Library." So authors from University of California at Irvine gave these nice details that with more than applications with more than 500 million to 100 million installs, such as Uber, TikTok for social, or eBay or Amazon, have vulnerable libraries, and they provide the name of the vulnerable libraries that they study how much time does developers take to provide a patch for those libraries or a solution to overcome the vulnerability that they have reported, and also how much time do developers release new versions still from these already vulnerable libraries. So yeah, I highlighted in red, GibLeaf is one of the libraries that Android applications also rely a lot, also OpenCV mainly for computer vision. And you can see that being used in Uber. And yeah, so here on the other side, they provide how many time or the average time it takes to fix developers take to fix in average a mobile a vulnerability that was reported. For instance, can take as much as 136 days for GibLeaf, which was reported in Airbnb, but also keeps a little bit higher when for the case of OpenCV, that can take up to 430 days. But this is not paired with how much faster, which is three times faster than how much faster a new version of this library can appear. And then you have different versions of these applications, but we are not really sure how developers are keeping track of the vulnerabilities that are discovered. So yeah, with these facts, it's so we raises awareness of how we are receiving as a users information that could help us do better decision on what applications we would like to install and interact with. And the purpose of this research is not to scare people, but just to provide more. From the research, we provide more facts that people can rely on to make more informed decisions. So I work in this area, and also security. So the problem or the situation where applications rely on native library calls also have brought in history might be the reason why we saw we had some cybersecurity attacks. So I will talk about two that overview. For instance, Heartbleed bug, very popular in 2014, which was open SSL cryptographic library vulnerability that affected this library. What affects is the internet security that is provided to encrypt your confidential information as password or username. And it leaked around the world around 64,000 usernames and passwords. And another more relevant to the Android world is stage fright that happened in 2015. And this affected all the systems, all the versions 2.2 that were called Froyo. And it's related to integer overflow vulnerability in a library that's called stage fright library. So this library, if you do a quick research, it's intended to deal with multimedia, MP4 format, and also the handling of multimedia messages in your phone. But attackers that know how to manipulate an integer overflow vulnerability craft some information behind this, for instance, sending you a message, and can access some registers in your memory to leak some information. So yeah, so this is still vulnerable for Android because some of the versions were provided with a patch, but others are still have this vulnerability. So if we were to taking forward the Android case, if we were to do analysis on how can I address security vulnerabilities in the binary layer, right now with the state-of-the-art techniques, the analysis works in two independent phases. So the first deals with analyzing the Android source code or application code itself. And the second, you need to, apart from that, analyze the stage fright library in the case of the attack from 2015. So the problem is that, okay, you can say I can dive into analyzing the Android application code and then analyzing the binary, but both of them by themselves have their own challenges, and the extra added challenge of having them independent is that at some point you need to combine. So that means that you will need to find a way or a mechanism to propagate how the information relevant to a certain vulnerability can be passed from the application side into the binary layer, and that's the huge challenge. So we developed a sample Android application to play a little bit with one of the most popular vulnerabilities that's called buffer overflow. So in a buffer overflow vulnerability, this is a situation when we are using some low-level C functions to write something, like, for example, a string. And that is written into that that variable or that information is written in a piece of memory that only has certain length. But the problem occurs when we are trying to write something that either exceeds the capacity or of the container that receives that information in the native library. And what happens behind is that, for example, if in the Android application we are going to send the red block, and the red block has the length that we can visualize by the white symbol, then if the container is just as long as the green capacity, then since you send a higher or a much large piece of information, you will cause a buffer overflow in the native interface side. Also, I can be a little bit more creative, and since behind the scenes, I add some other piece of information that it's graphic here by the yellow container. So the red plus the yellow actually could overflow the capacity of the container in the native interface, and this also can produce a buffer overflow vulnerability. So the real problem behind a buffer overflow is that inside the memory, when this happens, this can overwrite the later memory addresses that were used when you try to copy in a normal setting. So when some memory addresses in your device are overwritten, this can allow room to big problems to happen. And big problems in this case could be that I find another way to come up with and know and read what information was left in those memory addresses. And then I could have a way to leak information. So our small example actually recreated this case. So we have wanted to explore buffer overflow, and this overwrites. We know that the worst case with the buffer overflow overwrites memory addresses. So if memory addresses can be leaked, memory addresses are overwritten. So there are mechanisms that can be created to leak information. And when you leak information, then you are using a vulnerability to have a security implication. In this case, then we can have a security or a privacy attack. So itself, the vulnerability is not bad, but it can be used in a way that can produce an attack and vulnerate your critical information or your personal information. In a bit more of detail, this is how we implemented or transitioned from Android through a native C library call. So Android communicates with a Java native interface, and the Java native interface calls itself to the binary library. So here you can see that in the native library side, the capacity of the password container, the container that will receive the password to, for instance, verify if this is a valid password with another server, it's 64 character capacity. So the way we copy in the native C library the password matters, because there are some ways that we can copy the strings we are getting from the buffer such that the extra characters can be leaked further in the memory addresses that are overwritten after a buffer overflow. So for instance, this way, when we are not verifying the capacity of the string that we receive, it's a vulnerability because we're not providing a bound check before starting to copy the actual characters of the password. And in the case that the password exceeds the capacity, the coming password exceeds the capacity of the declared buffer in the native library, we could have a way to say, or to raise a flag and say, this is going to perhaps end up in buffer overflow situation. So this is how a test scenario look like for our toy example. So in the first part, you see when it's under the string password, we send a password and we have 64 characters, but when we started to send a little bit more, this is what we received. And you see that the received, at the end of the received string, you have a little variation. So this variation can be interpreted as the corruption that we read back in the Android itself. So this means that some information was left in there while the native library was trying to copy the password. And if I know how to access to that memory locations, I could perhaps leak those characters and start trying to figure out. So now I'd like to move to why is it hard to do native binary analysis itself. So the situation with native libraries is that they are stripped out any context or any meta information that could help you to navigate and see which part is the function that is copying the string password, or which part is the one that is provoking the buffer overflow. So there is no documentation, it's not a high programming level language where you can have comments or at least some hint what certain function is doing. And it can be very long. A library can implement as many methods as needed. And so without context, one way to approach is that all the entire library needs to be analyzed. And this, if all the methods in that library are analyzed, this will lead to high positive rates, because you would like to just analyze that particular method that it's linked with the buffer overflow, for instance. And there can be multiple representations of the language behind the native binary libraries. And for instance, there are a difference between binaries and binary libraries, which we refer as native binary, because there is a study that showed that mainly Android applications rely on binary libraries rather than on binaries itself. So I will continue with native binary term to refer to binary library usage. So our framework or way to address this problem is there are two components to this framework. The first, we are proposing to train a vulnerability detection engine that is able to learn vulnerabilities from already existing data sets that have already reported vulnerabilities existing at the binary layer. But these vulnerabilities are not in Android language. They are in their own language, which can be C, C++. But they contain the workflow or how does buffer overflow or some vulnerability behave. So we train a model to be able to recognize the parameters or characterize these vulnerabilities. And then we test with what we introduce as cross-layer context-added inputs, that are the inputs that are capable to craft the information from the Android application, the relevant information from the Android application associated to a specific interaction with that vulnerability. So then we can use our deep learning or intelligent engine that was trained on recognizing a specific vulnerability or vulnerabilities with the specific cases, for instance, in the Android applications. And so if the motivation behind the vulnerability detection engine is that we can define a security property. For instance, I'm very concerned about information leakage. So what are the vulnerabilities that are associated with information leakage? So for instance, buffer overflow, and another one is out of bound error. So I pull vulnerabilities or programs that have been labeled and already reported and are publicly available to understand and train a deep learning engine that could learn what is the characteristics or learn to recognize these related vulnerabilities that are linked to a security property I want to study. So in program analysis and when trying to breach domains from program analysis security to the deep learning or the learnings world, there needs to be some processing. So it is one of the processing we need to do from the vulnerabilities on the source code that we have available, publicly available from these vulnerabilities, is it's called intermediate processing that helps us to have the code transformed into vectorized inputs. And these inputs are fed into a deep learning architecture. And in this case, it's a recurrent neural network architecture, because authors have overviewed that the specialization attention given to sequences that are characteristic of recurrent neural networks can be very beneficial to this problem of analyzing codes and also how they characterize a buffer overflow or a vulnerability throughout the syntax and semantics of a code. So we got the train parameters and the weights, and this is the training phase. And now the testing works as, okay, now we need to be able to use our framework to detect the vulnerabilities in Android application, for instance. So we need to craft the relevant input, the relevant information, and see what type of vulnerabilities are we able to detect based on the train parameters that we got from the previous phase. So in a graphical nutshell, this is how the learning approach for our system works. If we were interested in detecting or in addressing, in detecting security vulnerabilities in Android application, for instance. Yeah, and this is a table that can give some information of the more reliable information of some metrics that authors have reported that already implement these RNN or recurrent neural network structures into program analysis, trying to detect different vulnerabilities. And one thing to also point out is that these are imbalanced. Always we have imbalanced data. Problem with having higher number of non-vulnerable samples than vulnerable samples. And yes, why we use RNNs to take advantage of their attention specialization that we can use to recognize what piece of information is relevant for a buffer overflow vulnerability or other vulnerabilities. So we, at the moment, we gather our data from a BullDPker data set that it's a paper that released their data, and they have buffer overflow vulnerabilities with 8,000 C++ programs that are labeled for buffer overflow vulnerability. So one of the first challenges is that once you have the buffer overflow code, source code, you need to transform into some input that it's be able to be digested by a deep neural network engine. So you have the program source code, and then you need to have do a little bit of processing to extract the relevant information related to the vulnerability you are trying to use, and then do an encapsulation of that information, and then translate those slices of code into code gadgets, and these code gadgets will produce a vectorized or numeric input that is compatible with a deep learning input. So for a specific case, this is how we started to, I wanted to show you how does this process look like for us. So this is one type. There are millions of type of buffer overflow. So this is actually one type of bound check where we have two functions. The first copy function 1 does not implement, is not safe. So actually that can produce a buffer overflow. And this is how the intermediate representation look like. So we work with this data, and this is also the intermediate representation. It's very similar to assembly instructions. And these are the information we use as a source to characterize how buffer overflow. So out of this instruction, there are some hints that can help us to characterize what is the source instruction that actually is not doing the bound check or is allowing room to leak information. So once we have this low-level representation of the programs of the labeled vulnerabilities, when we work with, we need to plug a way to have the vectorized representation for them. So right now, the current task in this research, we're working to graph or use our low-level representation into vectors, numeric representation. So we are studying code-to-vect, that is an embedding technique. It's a very nice learning distributed representation that authors have provided, and it looks like this is a recreation that we did out of their available code. So you input a function, and this function, the purpose of this function is to compute the Fibonacci of a number. So this function is written in Java, and the engine itself will give you with some probability that you can see here at the left part, what's the name or what's the best descriptor for the content of the function you are passing through. So it's actually like guessing the name for all the meaning or all the semantics of the code that you are giving as an input. So it provides the name that it will relate to what the function is doing, and it does so, but using some context, but by building some context out of the code, out of a graphic representation of the code, and then assigning an attention value to see what are the relevant contexts that can give a better guess of what the function is doing. So this is a replication of the work that code-to-vect does, and we are in the process of having the representation be done for the LLVM bit code that we have to characterize our vulnerabilities. So this is the last slide. I know I'm a bit off time, but so the field of binary analysis, it's rough, but it can offer high fidelity to reason what is the real problems that are causing some security issues. And as you see in the first example, it's something really relevant we need to address along the development of new functions or applications. For instance, there are many applications that are coming for the IoT world, and mainly these, and more likely all these programs that, for instance, are coded in Arduino, they always make a call to a C library. And you are using a servo, that servo will be implemented, the functionality itself, in a C library. So that library needs to be checked. What vulnerabilities is the code having? So the end goal of our framework is as such. So provide a way to detect vulnerabilities so that better software can be released. And with this, I'm very happy to take any question, and thank you.
Wonderful. Thank you, Salome, for the wonderful presentation. Please give a round of applause for Salome.
Thank you.
So we can open it up to the audience now. Does anybody have any questions? I'm happy to ask one in the meantime. So if somebody is looking to get started, to learn a little bit more about cybersecurity solutions, what is perhaps a good resource that they could look to perhaps get started?
So I'll say that perhaps when we listen to news happening about in the newspaper or in your daily podcast about some cybersecurity attack that happened, it'll be a way to do that will be to pay attention to what vulnerability they found. And if you know the name of the vulnerability, you could eventually in the future, you could do your research to see what type of, for instance, integer buffer overflow means, but there is no way to actually right now link that to the application you are using if you want to make sure that your applications in your mobile phone are not prone to that vulnerability. But at least you know what vulnerability they are working on. And if we become, I guess that we become more aware of the vulnerabilities we are also exposed to, we could request more security bounds from the applications we're using, or security, not maybe bounce is not the word, but to request that the applications we use at least have some of the basic vulnerabilities covered or a solution for those. And after, I don't know, maybe having a playground as you can have for neural networks where you can plug your image and then transform it or see a generated face out of that. That would be nice to have, that if you plug your code of your applications, if the system is built, I could give you a hint of what vulnerabilities I have discovered. Yeah. I'm not sure
Fantastic.
if I answered the question.
No, I think you've answered the question, and you gave a lot more insight to other aspects as well. So thank you for that. We have a question from Andres, who says, "Great presentation. What if an IoT application is not connected to the cloud or any Wi-Fi or Bluetooth networks? Do they still have the same vulnerabilities?"
I'll say they will likely have, because any IoT device, so they won't have buffer overflow, but there will be also perhaps another vulnerability that is related with the data management itself. So at some point, they will need to communicate with something. Not right now, there is a very interesting idea that UAVs can be actually used as middle point connection network before reaching to the cloud. So at some point, you will need to transmit some sort of data. And even if you are not passing the password, you can pass just a number. But attacks can be grown in the intelligence itself. So even if I pass one number, after some time, that number could become sensitive information. Like you wouldn't know that the password, I mean, of course, password is sensitive information, but a password, but plus something else, if I encrypt it and then I pass it, and then I know how to manipulate that information, that could be also risky. So I would say that, maybe in some cases right now, it's not imperative, but overall, it is, because at some point, the issue relies on how much you interact with native libraries and how native libraries process the data in the microprocessor. So if you leak information there, or you are using memory there that's able someone that is leaving a path, because as long as you leave a path, someone will have the understanding at some point in time of finding a way to go back to that point. And might be critical for some applications, might be not, but that's so far my understanding. I don't know if I answer your question.
Yes, thank you. Thanks for your answer.
Okay.
Any final questions for Salome?
And by the way, if you have any feedback or things that you spotted that do not make sense, or any critiques, are very much appreciated. And there is my contact email there. I will very much look forward to hearing from you.
Excellent. Well, if there aren't any more questions, please give one final round of applause to Salome Perez for the wonderful presentation. Yes, and so this wraps up our March AI Meetup. This meetup would not exist without the support of our community. So please, let's connect. If you have any questions about the meetup, or if you are interested in presenting at a future meetup, we'd love to hear from you. And again, this meetup will be available on the YouTube page, but we also encourage you to go to our YouTube page to not just view past meetups, but we also have more technical presentations on that page as well, from the AI seminars and tea time talks from the University of Alberta, as well as other past lectures that we have hosted. So there's lots of content there to explore. And but with that said, we do hope to see you again next month at the same time for the April meetup on April 22nd. So once again, thank you to our presenters for sharing their time and expertise. Alex, Reg, Salome, do you have any final words or thank yous you would like to say?
the only thing I would say is I wish I could have done this in person. I would love to have sort of seen everyone face to face and you know, just feedback and, you know, maybe make it more interactive on the fly. I love that sort of approach. And if you get me in front of a whiteboard, well, then things really start to happen. Thanks, Vaughn, for inviting us to present. It was great. Hopefully it was good for everyone else. It was a great time for me, and even though I get all was super nervous and all that stuff. So.
Yeah, thank you, everyone.
Excellent. Well, and also thank you to our audience for joining us today. And we wish you all the best in the coming month. And cheers and have a good night. And we will see you next time. Take care.
Thank you.